AF is your gain with feedback. Okay, suffix vandale, the term feedback should be coming in your expression. So DAF by AF equal to DA by 1 plus beta A the whole square into 1 by AF. Substitute the formula for AF. AF is A by 1 plus A beta. So 1 by AF is 1 plus A beta by A. 1 plus A beta by A. Okay, just a second. So substitute the expression for AF. AF is A by 1 plus A beta. So 1 by AF is reverse of that. 1 plus A beta by A. So 1 plus A beta and 1 plus A beta will get cancelled. So you get dA by A into 1 plus 1 by A beta. Okay, so if you final simplification, you see DAF by AF equal to dA by A by 1 plus A beta. This is the final expression we get after substituting all the parameters, and you cannot simplify this anymore. Okay, so DAF by AF equal to dA by A by 1 plus A beta. See, whenever you write a parameter like dx by x, can anybody say what does it signify? Dx by x. What is the significance of writing this term dx by x? X, you know, it is the actual variable, and dx indicates the variation in x. So whenever you find a ratio, always you can say this dx term will be very, very small and x term will be, because x is the actual variable and dx is just a variation of x. For example, see, x is 10 and they say x can vary plus or minus 1. So this dx is going to be plus or minus 1. So when you find the ratio, plus or minus 1 divided by 10 is going to be plus or minus 0.1. So whenever you write this term dx by x, it indicates the variation, mathematical representation of the variation in the variable x. Okay, so when you see you have a term here dAF by AF. So similarly, I can say this dAF by AF term to be the fractional change in voltage gain with feedback. This term dAF by AF indicates the change in AF. So how much AF can vary, the change in AF. And dA by A indicates how much your A can vary. Remember, AF is after applying feedback and A is before applying feedback. It is the actual gain of the amplifier. Okay, and remember 1 by 1 plus A beta is called as sensitivity. It's just a notation. Okay, 1 by 1 plus A beta is called as sensitivity. And you see here, dAF by AF equal to dA by A by 1 plus A beta. So this dAF by AF is varying even in a very, very lesser way. dA by A is the variation in voltage gain without feedback. It is divided by 1 plus A beta. When you divide any component by 1 plus A beta, the value gets reduced. So what they are saying is, when you apply negative feedback, dAF by AF, or the change in voltage gain with feedback, will be very, 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 very small. And the fraction which divides the ratio is 1 by 1 plus A beta. 1 by 1 plus A beta is called as sensitivity. See here, Sensitivity is the ratio of change in voltage gain with feedback to the change in voltage gain without feedback. So change in voltage gain with feedback is dAf by AF. Change in voltage gain without feedback is dA by A. So the sensitivity is given by 1 by 1 plus A beta. This is the sensitivity definition. So remember dx by x. You have to remember this analogy. Only then you can understand what is dAf by AF and what is dA by A. So dx by x indicates the change in the variable x. How much fraction change your x is undergoing from x to dx. Okay. So same with dAf by AF means the fractional change in the voltage gain with feedback. dA by A, the fractional change in voltage gain without feedback. So the parameter which is going to relate both is called as sensitivity. So sensitivity is equal to dAf by AF divided by dA by A. So it is 1 by 1 plus A beta. Okay, I think that should be clear to you. See, that is what is given. If sensitivity is 0.1, then the percentage change in gain with feedback is 1/10 the percentage change in gain without feedback. If sensitivity is 0.1, which means that sensitivity is 0.1 means if the dA by A is varying by a larger amount, dAf by AF will vary only by 0.1 or it is 1 by 10th of the percentage change. So essentially what we claim here, when you apply feedback, these things are going to vary. The AF variation is going to be very, 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 very less when you compare to the variation in capital A. Okay. And the reciprocal of sensitivity is called as desensitivity, capital D. And capital D is given by 1 plus beta A. If sensitivity is 1 by beta A, desensitivity is reciprocal of that. So sensitivity S is 1 by capital 1 by 1 plus beta A. D sensitivity capital D is 1 by S or 1 plus beta A. Okay, so now I can write the gain with feedback AF is given by A by 1 plus A beta or A by capital D, because 1 by A 1 plus A beta is going to be capital D. Okay, so AF is equal